And this is a very important slide, so I will spend a minute or two on this. So microarray data, when you input it, has to be in a standard format, okay? And the tool is it doesn't have to be microarray data, but the way in which you order this type of numerical data has to be strictly. And if it doesn't load, then it's something that you have done, okay? Say that now. So the first thing that you need is a unique probe ID, okay? So this is your identifier which describes what the data point is that is going to be a node in the graph. Now you can put just the probe ID in there. The trouble is, do you know what any probe means? Can you remember 50,000 probe sets and what they mean? No, of course you can't. So it's useful to have the gene name. The other reason to have the gene name here is that actually you kind of know gene names. You might want to search for a gene name, and this is the column that the tools will search upon when you ask it to show you CSF1R or one of those genes. It'll look in this column here for the identifier you search for, so you better now, because often on microarray experiments then you have multiple probes for the same gene, you may well have, as in here, ZZZ3 represented 6 times on that array, okay? So the way you make ZZZ3, so if you put just ZZZ3 in it, then that's not a unique identifier because there's 6 nodes potentially, or 6 sets of values which have that. It doesn't know which one you're talking about, and it will not generate 6 nodes with ZZZ3. So that's why you need to put the unique identifier in here, okay? First column, unique identifier. Okay, the next thing, of course, is that sample ID. As I mentioned, make it simple, make it clear, make it understandable, because it's gone up in sample Z36786. What does that mean? Okay, control 1, brain, whatever it is, you call it something that is a meaningful name and that you understand what that sample is and where it came from, so that when you see something strange happening in that sample, you can immediately track it back and you know what the hell it is you're looking at. So, as I mentioned, sample classes. So, sample classes is time, it's disease, it's replicate number, it's any of those things. Now, this is a relatively new thing that we can do in BioLayout, but you want to put them in, okay? So that you list the sample name, and underneath it that it's a B cell, that it's a B2 B cell, that it's in replicate 1, and I'm not sure what A and B mean in that case. It means batch. Okay, they were ran in 2 batches. So you basically have this information, and the reason that we have this information is that we can overlay this information on top of the graph, and we can start understanding what that relationship is. Okay. Similarly, you have other information about genes before you start. So you may know that you have a Go ontology for it. You may have done a statistical analysis of your data. You may think that you know which ones are interesting, and you have a hit of a statistical hit. These are some things, again, that you can say, look at the graph as a whole and say, where are my statistical hits within the graph? Because you can select these. We'll come back to class sets later. And then finally, it's your numerical data. Okay, that's the numbers that come off the machine, or the numbers that you come off the machine that you've QC'd and you have normalized. Okay. The other thing that bioinformaticians love to do to data straight off is to turn it into log2. Okay. Now, if you know what log2 value 8 means, then you're a better person than me. I can't think in log2 space. Okay, I think as these things as just being raw measurements, and I understand the difference between 100 and 1,000. I'm less familiar with understanding the difference between log2 7 and log2 10. If you can, then, well, even if you can do that, which makes you better than me, the problem is with when you log data, what you do is you flatten the top and you increase the bottom, and in terms of correlation space, that makes kind of noisy data correlate more than others. So you will get a graph if you put log2 data in there, it just won't be as nice. You won't understand what the clusters are quite as nicely. It'll be roughly similar to what it would look like if you put natural scale in, but it will not be the same. So make it sense. So once you've put all of that together in Excel, and once you become, used to what you're doing, you can do it in a few minutes. Okay, so the biggest time I take when I've downloaded a data set from Geo is the time to get it into this format, to go, oh, what the hell is this sample, give it a proper name, work out what it is. That will take me a good half an hour, 3/4 an hour, just to get, if it's a big enough data set, and then I can put the data in. Okay. Now, even if you don't put it into natural scale, there is a way of changing this around. So once you've done this, you must save it as a tab separated file. Okay. And you will save it as a text file. And you must put this inverted commas. So Excel likes to name everything you save as a text file as .text. If you save it as .text, then it's no longer an expression file. So by putting these speech marks around the name that you've given your sample, it'll actually stop it putting on that .text. God, that's my phone now. Right, it's soft enough to not to hear. So, and a file on your desktop, which will, certainly if you've got the latest version of that, will have a little icon that looks a bit like that at the top. We've just inserted a new icon into the tool so that your files will have that little icon at the top there.